Okay, so now we are recording, and after class, I will share the recording by maybe OneDrive, so you can check if you can see the recording. Okay.
OK，老师。
OK，谢谢老师。
OK，老师。
Okay, 不客气. So you are trying hard to learn Chinese, right?
Yes, 老师.
Yeah. Okay. So here we try to write like this: limit n right arrow infinity. Here we write the sequence. So here that is 1 over n and equals to 0.
0.
Yeah, so this is the limit of a sequence. So now we are going to learn the limit of a function. So we know the sequence is a special kind of function. For example, we have learned what is a function, right? So maybe most of the time we write like this: y equals f of x, right? And here we know sequence is a special kind of function. So most time we write, if we want to write the sequence as a type of function, mostly we write xn equals f of n here, f of n. That means f(1) equals to
F1.
x sub 1. Yes. And fn equals x sub n. So now, as we have known the definition of the limit of a sequence, so now we can know the definition of the limit of a function. Yeah, here. So maybe here I will give you a special kind of function, that is y equals to 2. So we have learned this is the basic function, right? We call it constant function. And we know no matter which value x is, that y always equals to 2. So this is a graph of this function. So now I want to know, as x approaches 0, how does the function y equals to 2 behave? That means as x approaches 0, so we can see either x approaches from the left or x approaches from the right, right? So we can see y always equals to 2. That means the function get very close to always this number, this constant 2, right? So here we know as x approaches 0, here y approaches 2, right? Y get very close to 2. And here I will give you another example to show the limit of a function. For example, here y equals x, y equals x. So the graph is a line, right? Remember that?
Yeah.
Yeah.
Yes,老师.
Yeah. Oh, sorry. The line passes, passes the original point. Yeah. So this is y equals x here. Y equals x. So we also want to know as x approaches 0, how does the function behave? Here the function that is y equals x, right? So we can see as x approaches 0, here y here, right? The value of y approaches 0 too, right?
Yes.
So so now we know as x approaches 0, here y also approaches 0. So here we have the definition of the limit of a function. We say as x approaches to the point x sub 0. Here we use x sub 0 to means here, the point. Okay, so as x approaches x0, f of x always get very close to a single constant, single number f of x0. Then we say, or here I can use, maybe I can use a more simple letter here. Okay, so maybe here I can use capital L here. Yeah. As x approaches 0, f of x, the value of f of x approaches to this value, this constant. So we say L is the limit of this function as x approaches x0. And we also use the same symbol here. So we write limit x approaches x0, the function f, the limit of the function is L. So we also use this symbol here to mean the limit of a function. So for the first example, we can write as x approaches 0, the function that is y equals 2, right? So here, 2, that equals 2 here. And the second example, we can write like this, as x approaches 0, the function that is y equals x, right? So we write x here, that equals 0. So here is the definition of the limit of a function. But here we can see that is an informal definition because we use the words like the phrases like get close to, get very close to, get close enough to, right? So that just describe the behavior of the function of the limit. So guys, can you understand?
Yes, sir.
Yes, sir.
Yes, Sasha.
Okay.
Yes, Sasha.
Okay. Okay. So here is a definition. And for the definition, I want to emphasize one thing. This is very important here. I use the star here. That is x approaches x0. Here, the first thing I want to say that this is real line, and here is x0. We can see x approaches x0. We have two sides, right? From the left and from the right. So here, x approaches x0 from two sides. And the second point I want to emphasize that is x approaches 0. We can let x get very close to this point x0, but x cannot reach the point x0. So x approaches x0 means x gets close to x0,
On the
but
left and the right.
not the point x0. Am I clear now?
Yes.
Okay.
Yes, sir.
Okay. So here I want to say, no matter the function at the point had the definition, we can have the limit. Okay, I will give you an example here. Here, I want to explain that, for example, maybe the function that is here. equals to x by x. Okay. This is a special function. The first question I want to ask, that is, fx equals x by x and another function that is 1. So the first question is, these two functions are the same?
Ouchie?
Yeah.
No.
No, no, same.
Why? Why they are not the same?
They don't have the same domain.
Yeah, excellent. Why they don't have the same domain? Guys?
The first function x cannot be 0.
Very good. Very good.
Putting on x equal to 1.
And the
Yeah.
second, it's all living numbers.
Yeah, very good. Remember that the first class I have told you, right? Yeah, to check if two functions are the same, we must have the same domain and the same rule, right? So here, for the first function, the domain of this function, x cannot be 0. But for the second function, x can be all real numbers. That's why they are not the same. Okay, so here for this function, we know x cannot be 0, but we can consider the limit of this function as x approaches 0. So here, as x approaches 0, the function that is x by x, right? Remember that I have told you that x approaches 0 means x cannot be 0, right? So,
Yes, Lauchi.
so 2x both up and down can be cancelled, right?
Equals 1.
Yeah,
1.
the limit is 1 here. So from this example, we can see although the function does not have the meaning at this point 0, but we have the limit as x approaches 0. Am I clear, guys?
Yes.
Yes, Lauchi.
Yes, Lauchi.
Okay. Yes. So when we calculate the limit, we don't have to consider if this function has the meaning at this point. Okay, so this is a very important point for the definition of the limit of the function. So this is the first, and then we know the second, that is we can remember two here. We can remember two limits we always use here. The first, yeah, don't write on the screen. If you have some questions, and you can tell me, okay? Then write on the screen and don't forget to remove it, okay? So the first limit rule we often use, that is, if the function that is a constant function, if f(x) is a constant function, then the limit of this function as x approaches any point x0,
Always see.
yeah, always equals c, right? At the first example just now, here, right? So this is the first fact we always use. And the second, if fx equals to ax plus b, then we know that the limit x approaches x0, fx equals to, we can substitute x0 into this function. So that equals to a x0
plus
plus
b.
b. Yeah, so for the previous second example here, we know y equals to x, right? So as x approaches 0, then fx approaches 0 too.
0.
Yeah, we substitute 0 here. And why we have these two facts here, we use the precise definition of the limit of a function. And that definition is a little bit abstract, and it has a special name, and its name is epsilon delta definition. Yeah, so here you just know this definition, that is okay. And this definition
Can you
is
repeat the name, please?
Can you repeat the
Can
name
repeat,
of this?
can repeat.
Epsilon delta. Epsilon delta definition. That is the precise definition of the limit. And we always use this definition to prove the definition exists. So for our students now, we always do the calculating, right? Calculating the limits. So you just know this definition, that is all, okay? And try to understand it. So here, the definition is for any, here, the symbol means any. And the first letter A, upside down, okay? So for any epsilon larger than 0, we have here, this symbol means exist. The first letter E, left, right, and here exist delta larger than 0. 1 absolute value x minus x0 here. Here we know this absolute sign here means the distance, right? X minus x0 larger than 0, smaller than
1.
delta. 1, we have the function f of x minus a absolute value, the distance of fx and a always smaller than epsilon. So that is the precise definition of limit as x approaches x0 equals a here. Okay, so for this definition, we can use this definition to prove the above two facts. So here, maybe this is a little bit hard to understand for you now, but just know it. If you want to know more, you can talk to me after class. Okay. So here for the definition of the limit of function, you just know how to describe the limit. I mean, describe the limit means get very close to, and then we know the symbol of the limit, and we know the facts we always use here. That is okay. So here I will give you some examples here, and for these examples, we can calculate the limit here. For example, here, as x approaches 1, x plus 1, the function of x plus 1. So now we can say out this limit directly, right? So here we know, yeah, we can substitute 1 into this function, right? So here we can write that equals to limit x approaches 1. Don't forget to write this symbol at every step, okay? We should write it. And then we substitute 1 into this function. So that equals to 1 plus 1.
1 plus 1.
Yeah, 1 plus 1. Okay. So here we have that equals to, as x approaches 1, 2 here, right? And here it is a constant, right? So that equals 2 here. So guys, can you understand what I am talking?
Yes, Lashe.
Yes, Lausi.
Okay,
Lausi.
good.
Understood.
So please tell me, as x approaches 2, 2x minus 1, this function, the limit of this function equals to?
3.
Yeah.
Lashe.
Yeah, really easy, right?
3.
Yeah, really easy. So here we have the first rule, the first tip to calculate the limit. That is substitution, right? We just substitution the point x0 into the function. If we can get a number, that means that number is the limit of this function. If we cannot, that means the substitution rule does not work here. So we can try to find some other ways to solve it. For example, I will give you an example here. For this one, maybe x approaches to 3x plus 4. This is a rational function, right? X plus 5 here. So guys, tell me the limit of this function.
3. 3
Sir.
teacher.
3?
3. Yes.
1 Lashe.
No. No.
1.
No.
No. It's
7.
divided by 10.
Oh,
7.
10 by 7 Lashe. 10 by
Yeah,
7.
yeah.
10 by 7
Yeah.
Lashe.
7 Lachi.
10 by 7 Lashe.
How can you guess 3? Okay, here I just told you that the first way to solve the limit, that is, we can substitute the constant here, the point here, into the function, right? So here we just substitute 2 as x here. So that equals x approaches 2 here, right? The same, don't forget this symbol. And then we can calculate 3 times 2 plus 4. Yeah, over 2 plus 5. Yeah, so that equals to 10 over 7. Right? Yeah,
Yes, ma'am.
so the limit of this function, that is 10 by 7, right? Okay, and now I will give you another example. That is x minus 2, x plus 5. So what the limit of this function?
0.
0 by 7.
0 by 7.
Yeah,
Zero.
excellent. Yeah, we just substitute 2 into this function. So 2 minus 2, 2 plus 5, and 0 over 7. That must be 0, right? Okay. And next one here, x approaches 2 here, x plus 5, x minus 2. So now,
Infinity.
7.
Infinity.
7.0.
Infinity.
yeah, different voice appears, right? So here we also use substitution rule. We substitute it, that is, as x approaches 2. Here, that is 7 by 0, right?
Yes, ma'am. 7 by 0.
Yeah, so now we know that must be infinity.
Finish.
Yeah, so that means the limit,
Is infinite.
yeah, does not
exist.
exist, right?
Yeah, Lashe.
Yes, ma'am.
Okay,
Yes.
and
Yeah.
here is another condition that is, okay, here, x of
Lashu, why
Mhm.
why first one is 0, but this one is like does not exist?
Okay,
Because it's
so
same.
here, okay, same, really? So here you can see the numerator here that is 0, right? Denominator here that is 7.
7.
So
You can divide 0 by
yeah,
7.
numerator
0.
can be 0, right? So 0
Yes.
divide every constant, everything
0.
that is 0, right?
That's right.
Mhm.
Yeah, and here the numerator is 7, but denominator is 0. That means it not exist. Yeah.
Sorry, Lashu, I saw it's same for this reason. I
Okay.
think why it's 0.
Okay. Upside down, right?
That's
Okay.
right.
So the last example that is here. X squared. Oh, sorry. Here, x squared. That is x squared minus 4. So can you guys try to calculate this limit?
0.
0.
Zero.
0.
0.
0 Lasshi.
Okay.
Zero by zero. Zero by
Don't
zero.
be in a hurry. Don't be in a hurry. So try to write down
Infinity.
your steps. Okay, guys. Try to write down your
0
steps
by 0. I think it may be infinity function.
and send it
Infinity.
into
That's
The
four.
answer is
WeChat
0
group.
by
Let's
0.
check. Not
100%
0. The first thing, not 0.
4 now.
Why,
Yeah,
Lashu?
4 is correct. So try to write down the steps and send the steps. Send the picture in the WeChat group. Okay. Okay, later when you answer the questions, you can turn on your microphones.
Loshi, can you tell me about the page and the book, the one we are reading now?
The page of the book. Let me check. Sorry, if I want to check the page of the book, I have to stop this slides and see the ebook. So now you want to check what kind of things. So maybe you can follow my steps, and after class, I will tell you the pages we have learned today. Okay?
Sure.
Yeah.
Sure.
Okay.
Sure.
Okay. Oh no, means, yeah. Okay, many students gave the correct answer here. Okay, guys, don't write on my screen, okay? Okay, very good. I see many students gave the correct answer here. So let's solve this problem. So here we often use the substitution way, right? So here we use the same, we substitute 2 into this function. So we want to see what happens here. That is, as x approaches 2, and here that is 4 minus 4. over 2 minus 2. Yeah, here. So we see that is 0 over 0. So guys, we don't know how to solve 0 over 0, right? That is not 0, and that is not infinity. So this is a special type 0 over 0. We call it a 0 by 0 type. So when we meet this situation, we always try to use other ways. So here, that does not work. So here we try to find another way to solve it. We can see here. Here, the numerator x squared minus 4, then we can factorize here, right? So here we know that is x plus 2 times x minus 2. Yeah, over x minus 2 here. And we know x approaches 2 means x does not equal to 2, right? So here, the same factor can be cancelled. Yeah, here. So we know that equals x plus 2 here. And then we use the substitution way again. That means we substitute 2 into this function. And here we know that equals 4. And 4 is the limit of this function. That is what we want for this question. So guys, can you understand how to solve this kind of question?
Yes, ma'am. Yes,
Yeah.
yes.
Yeah.
Yes, yes, Lasha.
So first, substitution, right? When it does not work, we can use other ways to try to simplify this function. And then maybe we can use the substitution rule again. Am I clear?
Yes,
Yes,
Lashi.
Okay, good.
Lashi.
Okay. So here I want to tell you some ways to solve. Okay. So here I want to tell you some ways, or we can call it limit law here. We use a theorem here, that is the limit laws. Okay, so when we calculating the limits, we can use these limit laws, and sometimes it will simplify the limit, the calculating. Okay, so here we suppose the limit of the first function f of x as x approaches the point x0, that is a. And the second, the limit of the function gx as x approaches x0, and the limit that is b. So the condition here, that is the limit of these two functions both exist. Okay, so now the limit law, the first law, that is the sum rule. That means if I want to calculate, yeah, the limit of fx plus gx as x approaches x0, that equals to
E plus B.
Yeah, very good. Yeah, so that means here the sum of
Lasha,
two limit, right?
Lasha, it is a SM rule. I can try read.
Some rule,
What
some
the-
rule.
what-
Some.
Some rule.
Okay.
Okay. And here that equals A plus B, right? So here we can also get the difference rule. Okay, so means here that is f of x minus gx as x approaches x0. So now we know that equals to a minus,
minus B.
yeah, a minus b. And next one, we have the product rule here, right? That means if we want to get fx times bx here as x approaches x0, so that equals a yeah, times b.
Into B.
Yeah,
Okay.
a times b, a times b. And here is a special kind here. Special kind, that is, if we want to get as x approaches x0, here the first function, that is a constant function. So here I use c here, means a constant. So that must be c times
B.
yes. So now we can see we can get this constant outside this sign limit, right? So
Right.
that equals c times b. Okay. And next one, we have some difference, product, and then the third one, we have the quotient, right? And the quotient rule, that is here, as x approaches x0, fx over gx here. So here we should know that b cannot be 0, right?
Yes.
Yes.
Yeah, otherwise it does not have meaning. So here, b does not,
by B.
yeah, can't be 0. So here that equals a over b here.
Yeah,
Yeah.
over B.
Yeah, a over b. And the last one, last rule, we call it power rule here.
Power rule.
Yeah, power rule. Here, that means as x approaches x0, that here, f of x, here we have maybe power k, So here we know that equals to a power k. Yeah, yeah. So we can rewrite it as here, as x approaches x0, the limit of fx outside power k, right? So that equals a power k. So here are the laws we can use when we calculating the limits, guys. Okay, so here I will give you some examples and we can calculate here.
It's well.
Okay, Lashi.
Okay, so now I will turn to the next page. And if you didn't finish this page, I will send you this slides after class. Okay?
Just one more.
Yes, hello.
One more. One more.
Okay. Okay. And after class, I will tell you the pages of the book. So don't worry. Okay.
Okay, ma'am.
Here, the examples here. Which one? As x approaches 1, x power 3 plus 4x squared minus 3. And the second, that is x approaches 3, x power 4 plus x squared minus 1 over x squared plus 5. And the third one, x approaches minus 2 here, and square root of 4x squared minus 3. Okay, here are some simple questions, and try to tell me your answers as quickly as possible.
We have 10 minutes to solve this.
Yeah, finish the exercises here.
Last you need to submit that on WeChat.
Yeah, send the answers in the WeChat.
Okay, last you.
Lauchi, all of them.
Yeah, all of them. All these 3 questions. The questions are easy.
Lauchi,
Yeah.
can you see my answer?
Yeah. Okay. Who's talking? I'm checking the answers in the WeChat group here. Okay, I'm checking one by one. But some students sent the previous questions answers. And now I want you guys to solve these 3 questions. Calculate the limit here. Most students do the right thing and gave me the right answers. Very good. Okay, so they are easy questions, right? But there are some little mistakes here for the calculating. Maybe here. Okay, we can substitute one by one. So here we can see some common functions we often see when we learn this kind of function. We can call it
Polynomial.
Yeah, polynomial, right? And this kind of function, we call it rational functions. But no matter which kind of functions, we know the first way to calculate the limit, that is substitute, right? So we substitute the point into this function. So that equals 1 plus 4 minus 3. So that the first result is 2, right? And the second that equals here. Here we can use two-way here. We can see maybe the first we can write as x approaches 3, x power 4 plus x2 minus 1 by x approaches 3, x squared plus 5, right? Or we can write directly as we substitute the value here. So 3 power 4 plus 3 power 2 minus 1 and 3 power 2 plus 5 here, right? So we can get the result of the second one, that is 89 over 14.
540.
Yeah, by 14. And the last one we also substitute minus 2 here, so that equals to x approaches minus 2 here. So that is 4 times 4 minus 3, right? So that is square root of 13. Okay, so here are the results of these 3 questions. Any questions here?
No, actually, it is
No,
easy.
Lashi.
Lashi.
Okay, so
No, Lashi.
so now I will give you 2 questions. They are a little bit harder here. So number 4, try to calculate as x approaches 1, x minus 1. Okay. And number 5. Number 5, that is okay, there is some noise here.
Please mute your mic.
Okay, okay. Okay, now I turn off all the mics of yours, and when you answer questions, you can turn it on. So next question, as x approaches 0, square root of x squared plus 100 minus 10 over x squared. Okay, guys, so try to solve these 2 questions and paste your answers into WeChat group. And I will check your answers in the WeChat group. Okay, if you can now send your answers on the WeChat, it doesn't matter. It doesn't matter. As long as you can understand the way to solve these questions, that's all. Okay. Okay. So who has a question? So how to say?
13.
Amina? Do you have a question? Where it's not clear? You can ask me now.
Should I solve the question number 4 and 5 also?
Now we should finish number 4 and 5. So try to solve this question by yourself first.
Okay.
Okay. Okay, so how to learn math, the first step, that is try to think by yourself. And then I will tell you how to solve. Then you can really understand how to solve it.
One's answer is 0, Lashi, and the other's doesn't exist.
Yes, ma'am. Or different thing. 90 divided by 0.
Let me check your answer.
I think the answer is 4.
Okay.
One is 4 and another is infinity.
Yes.
Did you guys send your steps on the
I can
WeChat
find number 5.
Yes, Laoshi.
5 maybe infinity, but 4 I have no idea. 0, some of them 4.
Okay.
I changed my answer and we start group.
Maybe not correct for the number 5. So try to solve again. Yeah, as we can see here, number 4 and number 5, we get the 0 by 0 type, right? We get the 0 by 0 type again, so you cannot just substitute the point into the function. The substitution way does not work here. So how can we solve this kind of question?
Using law
Loshi, I have solved it. Should I upload it on?
I'm checking your answers on the WeChat one by one. Yeah, I do see some correct answers.
老师，我发过了。
好的 ，Nice Chinese. Okay, so here let's solve the number 4, and then I will give you some minutes. You can try to follow my steps to solve number 5. Okay, so here, okay, here. So here, when we substitute 1 into this function, we have numerator 0 and denominator 0, 2 here. So here we get 0 by 0 type. So we know we cannot substitute here. We have to find another way. And here is another way. That is, we have learned, I will write down here.
Have you checked the answer of question number 4?
No. Now I am telling you how to solve number 4. Okay.
The answer is 0.
Yeah. So now, okay, listen to me. We have learned when we saw, for example, x squared minus 1. So we know that can be written as x minus 1 times x plus 1, right?
Yes.
And here we have to know the reverse thing. That means when I give you x minus 1, you should know we can product one factor x minus 1 to make it equal to x squared minus 1. Why we want this square here? Because we have square root here, right?
Yes.
Yeah. So now the way we use here, that is, we time the same factor both up and down. And this factor that will make this square root away. So we use square root of x plus 3 minus 2 here, right? So
time square root x plus 3 plus 2.
Yeah, very good. So here, I will repeat again here. Because we see square root here, so we want to make the square root away. So we think we should square here. So we times the factor square root of x plus 3 plus 2 here. And if we time this factor at the denominator, we should also time this factor numerator, right? So that is x minus 1, x plus 1 plus 2 here. So this is the key step to solve this question. So for this step, Can you understand, guys? Anyone has questions here?
No.
No question,
No,
Raushi.
Raushi.
Okay, good. Good.
No.
Excellent. So here we know that equals to x approaches 0 here, and that should be okay here. For the denominator, so that equals square root of x plus 3 squared, right? Minus 4. So that equals x plus 3 minus 4 here, right? So that is x minus 1 here. And here we have x minus 1 here, and times square root of x plus 3 plus 2 here. So for this step, am I clear here? Any question here?
Raushi,
No, no, no.
Mm-hmm.
I have a question.
Okay, okay.
There is x tends to 1 and you did it x tends to 0. How?
The x minus 1 here or here?
No.
Raushi, under the limit.
Can I write?
Limit?
Yes, limit.
Oh, okay, sorry.
Yes.
Okay. Yeah, sorry. That is 1 here. Sorry. My mistake here.
Okay.
Okay, sorry. Thank you. Okay. Okay. So other questions here?
No, ma'am.
Okay. So here we have the same factors here, that is x minus 1, right? So they can be canceled here, right? So we know that equals to x approaches 1, and the function here, square root of x plus 3 plus 2 here. And then we can substitute 1 into this function, right? So here is 2 plus 2 equals 4 here. Yeah. So the result, the answer of the question number 4 is 4 here, not 0. So can you understand, guys?
I'm not gonna understand.
Yes,
Yeah,
Raushi.
Raushi.
Okay.
But not that.
So maybe now you can try to solve number 5 again. Okay, so the limit of the number 5, the result of the number 5 is not infinity. So try to do it again.
Raushi, it's 0.05, right?
Mm-hmm. Yeah.
Number 5. Yeah, I have sent it in the group.
Okay. Yeah. Okay, you don't have to write 0.05 or 1/20, that is okay.
好的。
Okay. Okay. Okay, here is a blue line. And so please remove this blue line. The boy, the careful boy. I removed the blue line on the screen.
Raushi,
Okay. Yes.
I can understand right here.
Oh, right here.
Yeah.
Here, because we have the same factor, x minus 1 here, so they can be cancelled.
We do that same.
Yeah, x minus 1, because here we product the same factor here. We should, to make it equal, we should time both up and down the same factor. For example,
Okay,
one,
Raushi, I get it.
you understand now?
Yeah, I got it.
Okay. Okay, so please remove the arrow. Super arrow here. Okay, thank you. Okay, so now maybe it is easy to calculate this limit. So now the same way to solve this question, we can product the same factor both up and down, because here we see 0 by 0 type again, right? So now that is as x approaches 0, here we product the factor x squared plus 100 minus 10. So here we plus square root of x squared plus 100 plus 10 here, right? And denominator the same factor plus 10 here. So now for the numerator, we simplify it. That equals to here square root of x squared plus 100 squared minus 100. So now we know that is, okay, that is x squared, right? And denominator, that is x squared times a square root of x squared plus 100 plus 10 here. Okay, so x squared can be canceled here. And then we substitute 0 into this function. So that is 0 plus 10, 0 plus 100. So that is 100. So outside the square root, that is 10, right? So that equals to 1/20. So the result of the question number 5, that is 1/20 here. Can you understand, guys?
Yes.
Mhm.
Well, I don't understand the single line. Yeah.
Yes, Sakshi.
Okay.
Difficult for me.
So if you have question, you can ask here. Your questions here. We cancel the same factor. We cancel the same factor here, x squared, right? And then we substitute 0 into this function. So here, that is 0 plus 100. So that is 0. Square root of 100, that is 10. So that is 10 plus 10 here. Can you understand?
Yes,
Yes, Larshi.
Yes, Lakshmi.
Okay. So here, up to now, we have learned the definition of the limit of the function and the limit laws, the rules we can use when we're calculating the limit. And now we will learn a theorem. The theorem, well, we have a name. This name, that is the sandwich. Yeah, that sandwich. The sandwich rule. That means we suppose in the book that is the theorem 4 on the book. The sandwich rule, the sandwich theorem means we can suppose that
It is sandwich rule.
Yeah, sandwich. Yeah, sandwich. Yeah. After I told you the theorem, the content of the theorem, you will know why we call it sandwich. Okay. So we suppose that the function gx smaller than the function f of x, smaller than the function h of x. And this is the first condition. And the second condition, that is the limit of the function gx as
Equal to limit of hx.
as x approaches x0. Okay. Okay. What is the question? I didn't see the question. Okay, the second condition, that is the limit of the function gx is L here, and the limit of the function hx is also L here, then we have the conclusion, that is the limit of the function f of x as x approaches x0, that is also the constant L. Yeah, because fx is in the middle of the two functions, and these two functions have the same limit. So we have the limit of this function is also the same constant L. That's why we call it sandwich rule, sandwich theorem. Okay, guys? So, yeah, so we can use the sandwich theorem to solve problems like the following question. Here, maybe I gave you that the relation, that is 1 minus x squared by 4, this function, smaller than u of x, smaller than the function 1 plus 2x squared. For all x is not 0. And here, I want to find the limit of ux as x approaches 0. So this is a typical question. Tell us we have to use the sandwich rule here. So we can solve like this, because we have the first condition, right? That is very similar to the rule above, right? And second, we have to check the second condition. We satisfy the second condition here, right? So we have to check as x approaches 0, the limit of 1 minus x squared by 4, right? And we know we can substitute 0 into this function. So the limit is 1 here.
1.
Yeah, and the limit of the other function as x approaches 0, 1 plus x squared by 2 here. And we can also use the substitution way here, right? So we know the limit of this function is also 1 here. Yeah, because here is 0, here is 0, right? So we know the limit of the left function and the limit of the right function, they have the same limit. The limit is 1. So by the sandwich theorem, we have the limit of the function ux, no matter which expression of the function ux, that should be 1 here. So guys, can you understand here how we use this sandwich rule here? Can you understand?
Yes, Asha.
Okay.
Yes, Lassi.
Yeah. When we want to use the sandwich theorem, we have to check these two conditions here. Okay. So this is the example for the sandwich rule here. Okay. And next one, we back to the, okay, I will turn to the next page here. Okay, we back to
Yes,
the,
Asha.
okay. What is your question?
Can I write
Oh yeah,
at the last part?
of course.
Okay, that's all. That's all, Asha. Thank you. That's all I write. Thanks. I was at
Are you writing on the
part.
screen?
Yes,
Rashmi,
yes,
just
I
like
finished.
studying this
I
test.
finished, Lasha.
Okay. 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 Some noise here. Some noise here. Someone is talking. I cannot hear your question. Okay. Maybe the internet is not stable here. I cannot hear your question. Or other students, can you hear the question?
No, Lasha.
Okay. Okay. So, if you have question about the above things, you can talk to me after class. Okay. So now we will continue. Okay, we're back to the expression of the limit as x approaches x0, f of x, the limit of fx, that is L here. And we talked about x approaches x0, and we say x can approach x0 from left and right. So for the left part, we can call it left side limit. And for the right part, we can call it right side limit. So here, I will give you the definition about one-sided limit here. Okay, so first, left side, or we can call it left hand limit. That means x approaches x0 from the left. So we can see if x approaches x0 from the left, that means x is smaller than x0, right? So when x is smaller than x0 and x approaches x0 from the left side, we can write the left side limit as this way. That is, x approaches x0, and here minus. We use the minus sign at the power here. And then the function f of x. And if the limit exists, we can write down as L here.
Roshi,
Yeah.
x0, it's smaller than x. No.
Why?
Actually, I don't understand the last line. Nothing.
Laushi, could you please repeat?
Okay, repeat again. Again. Here we have the limit, right? And x approaches x0. X is on the real line, right? So x approaches x0, we can approach from two sides, left and right. Yes? While x approaches x0 from the left, that means x is smaller than x0. Because that is from the left. For example, here is 0. Here is
Left is
-1.
negative.
Yeah, here is 1, right? If we want the value x approaches 0 from the left, that means x is smaller than 0, right?
Yes.
Yeah, so can you understand now?
Yes.
Okay. So here is the left side limit. And then we have the right side right side limit, or we can call it right hand. That is also okay. Limit. Okay, so that means x approaches x0 from the right. Yeah, when x approaches x0 from right, that means x is larger than x0, right?
Right.
Yeah, so here, if the limit exists, we call it right-hand limit, and we write like this: x approaches x0 from the
Plus.
right hand. So we write plus here. F of x equals L. So yeah, here are the definitions about left side limit and right side limit, or we can call it left hand limit or right hand limit. Okay, both are okay. And here I will give you a theorem. And this theorem, we use it to check if the limit of fx as x approaches x0 exists. Here, if we write down this expression, that means the left side.
Equal the right side.
Yeah, very good. The left side limit first exists, and the right side limit, yeah, also exists, and they should be the same. Yeah, they should be the same. Then we say the limit of the function f of x exists, and the limit is L. And the opposite way, that is, okay, that means here, if the left hand limit and the right hand limit both exist and they are the equal, then we say the limit of the function exists and is the constant L also. Can you understand here?
Yes, Lars.
Okay.
Yes, Lars.
Okay. So for example, here, maybe the function that is x, we always use this one, as x approaches 1 equals 1 here. That means the left hand approaches 1. Don't forget minus here, means left hand. And equals as approaches 1 plus here means right hand. Yeah. They should be 1.
Can you please repeat it again?
Repeat the example.
Yes,
or okay.
Repeat the theorem also. Repeat the theorem also.
Okay, so here we say the limit of the function exists. That means because we have left hand and right hand limit, so here we should have these two limits exist and they should have the same limit. Then we can say the limit exists. Can you understand? Or okay. So now I will give you an example to show this one, okay? For example here, and this example is a very typical one, so please listen carefully. And here I want you guys to prove the limit as x approaches 0 function that is absolute value of x by x. The limit of this function does not exist. Okay, so now we want to prove the limit does not exist. So here, how can we prove it? We see here we have a special function here, right? This function that is absolute value function. Yeah, and we have learned it before, right? And we know if x is larger than 0, then the expression of this function is x, right? And x smaller than 0, then the expression should be
Minus x.
Minus x.
Yeah, and the 0 you can write up or down, both are okay, or we can list it here. So when we know this absolute value function, okay, back to this limit, we should consider x approaches 0, right? When we consider x approaches 0, we know x can approach 0 from left and from right. And from different sides, we have different expressions, right? So here, we should consider left-hand limit and the right-hand limit one by one. Can you understand now?
Yes, Lord.
Okay. Okay. So we first consider left hand. Yeah, we first consider left hand. And here we consider as x approaches 0 from left. That means x is smaller than 0, right? When x is smaller than 0, we know absolute value of x equals minus x. Yeah, so here that is minus x by x.
Right.
Yeah, and here we know that should be x can be cancelled here, right? So the limit,
-1.
yeah, the limit is -1 here. Can you understand, guys?
Yes, Laoshi.
Yes, Lord.
Yes,
Yes.
Laoshi.
So now we consider the right hand. Okay, if you can understand the left hand, then I think you can understand
Yes.
right hand. Yeah, here, as x approaches 0 from right hand,
0 plus.
yeah, that means x
Greater
is,
than 0.
yeah, larger than 0. Good. So
X greater than
yeah, the
x is
absolute
x.
value x equals
X
x here,
By
right?
x
Yeah,
equal 1.
yeah,
is
x
1.
over
By
x.
equals 1.
Okay, so the limit equals 1.
1.
Okay,
One.
here we can see the
And the right side and
left
and
hand
right side-
limit
right
exists,
hand limit.
right? And the right hand limit also exists, right?
But
But
not
they
the
are
same.
not the same.
Not the
Yeah,
same.
very
But not
good.
the same.
But they are not the same,
Yes,
right?
Laoshi.
So
Yes.
here we have to write down, but the left hand of this function fx does not equal to the right hand.
Your
Right hand.
right hand.
Yeah, so
Yes.
the limit of this
Absolute value.
function
Absolute
does
value.
not
Exist.
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 Okay,
Does not
okay.
exist.
So we complete this proof here. Can you understand, guys?
Yes,
Yes,
Yes, Lord.
Okay, good, very good, very good. Okay, I will check the chat box. Okay, very good, very good. So,
Laoshi,
okay. Yeah.
you go back the previous page. I'd like to take a screenshot.
I didn't
Could you
understand.
go back the previous page?
Previous page, okay.
Like to
Okay.
Laoshi, where we can get the recorded video.
I'd like to take a screen.
Laoshi gave the PDF and recording, so don't need to screenshot now.
Yeah. I will give you the slides after the class.
Yes, Laoshi.
And, yeah, and
Yes,
I will
Laoshi,
also
okay, but-
tell you the pages on the book. Or
Laoshi, where you get the recorded video?
recording. Okay, after the class, I will share the link in the WeChat group
Okay, thank you.
by OneDrive. last year we use OneDrive, and most students can check the video. Okay.
Okay. Some of the teacher actually are posted on Chowting. Do you post on Chowting, Laushi?
Okay, so maybe I will share the link. If you cannot open the link and see the video, we will try another way. Okay?
Okay, Laushi.
Okay, yeah. Okay. By the way, we talk about the Chaoxing. I will talk about the homework here. Up to now, I only receive maybe less than 40 students' homework. So I don't know why. Maybe you don't receive my information or my homework, whatever. But I think every time you should submit your homework on time. Okay, guys. So after this class,
Can you,
okay.
sorry, Lucy, can you share the list who have submitted and who
Okay,
didn't?
of course. I will give you the
Actually, I'm
list.
confused. I have done or not.
Okay. I will give you the list after the class, and okay, from this time, I will send the homework by Chaoxing. And if you didn't receive my message, you can also send your homework to my email. Okay. Okay, this is my okay. One minute. This
Give
is
us your
my
email address.
Yeah, this is my email. Spell CHOUJING, my Chinese name.
Oh, yeah. Can you please read?
Zhou Jing.
I got it.
Yeah. Zhou Jing. Yeah. At SUES .edu.cn. Okay.
Laushi, can you write box?
Laushi, I have a question, Laushi.
Okay.
Laushi, could you please set a automatic reply? If we send the homework through the email, then please set a automatic reply.
For me, I suggest you guys send your homework by Chaoxing. Okay, that is easy. That is easy for me to get the list. But if
I also think, Laushi.
Okay. But if you cannot submit your homework by Chaoxing, and you can send your homework to my email, and my email has the auto reply. So if you got my auto reply, that means I got your email. I got your homework.
Yes, Laushi. Thank you.
Okay, and after class, maybe later today or tomorrow, I will give the list I received last time by Chaoxing. Okay.
Yes.
Okay. So after class, maybe I will give you some homework, and you should submit your homework before Wednesday. We have next class. Okay, and I will write down the specific information on the homework on the Chaoxing, and please check it. And I will tell you in the WeChat group when I send the message to you. Okay. Okay, so today's class is over, and see you Wednesday, guys.
Thank you, Laushi.
Okay, don't forget to have
Thank you, Lauchi.
We have homework today. We do have homework today. And after class, I will tell you the homework both on Chaoxing app and on our WeChat group. Okay?
Okay, Lauchi.
Bye, guys. Okay.
Bye.
Bye.
Bye.